Welcome. In this video, we're going to start covering Chapter 9. In Chapter 9, we're going to discuss a concept known as pointers. I'd like to give you a fair warning. For at least me, when I was learning C++, pointers was one of the more complicated items to grasp. Again, that might have just been me, but I do want to encourage you to take your time as you're going through this chapter to really make sure you understand all the concepts as we discuss them. So let's go ahead and jump on in. First, we're going to talk about getting the address of a variable. Now, we've already dealt with addresses in previous videos and previous chapters. And so I want to kind of cover a little bit about that just to refresh you. So remember that each variable in a program is stored at a unique address. So whenever we create a variable, that variable has an address associated with where it is in memory. And we can use that address operator, the ampersand sign, to get the address of a variable. So here we have int num negative 99. Now if we just said cout num, we would get negative 99. But the fact that we put the ampersand sign here, we're actually going to get the address of where this variable is in memory. And it's going to be in a hexadecimal format. So now let's talk about pointer variables. So a pointer variable is often just called a pointer, and it's a variable that holds an address. So we talked about variables that hold data. In fact, we've set up variables and we've assigned literal data to those variables. But we can also have variables that hold addresses that then point to data. So because a pointer variable holds the address of another piece of data, it points to that data. So imagine that you have a variable here, and this isn't the actual data of the variable. In fact, all it is a pointer to somewhere in memory. And starting at that space in memory is the actual data that we're looking for. As you can see, my mouse skills, because I don't have my pen out today, amazing. I appreciate that. Thank you. So I know you're saying, well, Professor Waits, why do we need a variable that holds an address to the variable that we need? Well, we'll get into that a little bit more, but understand that variables such as an address is a small piece of information that can point to much larger pieces of data. That's just one reason. So something like pointers, arrays. Now we've already dealt with arrays, and because of that, we actually have already technically been dealing with some pointers. And we've talked about that previous. For example, when we have a variable events, like here, I already said to you that the variable itself, numbers, is just an address to the very first one of the array. And that's why we need to know what kind of array it is, because this means every time we try to look at additional values. For example, value 0 would mean go to the address and add no additional int addresses to that. So value 0 is 1. If we said values 1, it's saying go to the very first address of values and go one int next, and that will bring you to the second element of the array, and so forth and so on. Again, if you don't really understand that, go back to the array videos and kind of watch those again. I go into a lot more detail about how we move from each element in the array. So remember that because numbers is an array, when we call the show values, it's actually passing the address of the array into the show values method. So we also have worked with something like pointers when we learn to use reference variables. And again, these are some of the things we've done in the past, and now we're kind of putting it all together. And remember when we're talking about, we had this function called getOrder, and it was int with the address ampersand sign donuts. Well, why did we do that? Well, we wanted to be able to have someone pass in a variable and allow us to change it within the actual function. To do that, we, instead of passing the actual variable, the int variable, we pass the address to that int variable, which then allows us to make those changes. Otherwise, if we had not done that, if we had not included this, remember what we said? We would have expected that this would have been a copy of the variable that called into get orders. And so when we make that change, it would only change it locally and not to the calling method. But by doing the address symbol, we can now make those changes. We talked about those reference variables. Again, when we did that, because we had the ampersand sign there, we're passing the address and not the variable itself. Pointer variables. So when we talk about pointer variables, it's another way for us to use memory and to our memory addresses to work with a piece of data. So that's the point of pointers, is that we are using pointers to reference memory addresses so we can work with that data. Pointers are more low level than arrays and reference variables. And I will also tell you that a lot of languages like C# and Java, they don't really have a concept of pointers. They take care of all that behind the scenes for you. But this, again, because C++ tends to have some more low-level features than those other languages, it's why we have pointers. And it also means that you are responsible for finding the address you want to store in the pointer and correctly using it. In fact, not doing it the correct way, you can overwrite memory that maybe the operation, something else is trying to use, I should say. So be careful when you're working with pointer variables. But it's a common thing with C++. In fact, as you develop in C++, at some point, pointers and addresses just become second nature. And at some point, you'll even go, man, I really wish this was in some of the higher languages, because there's a lot we could do with pointers. And there is, by the way, in a lot of these upper languages, ways you can kind of do it. And I'll let you do the research on your own for that. So a pointer variable, its definition looks like this. It's an int with the star, as you can see there, and then the name of the variable. So we read this as this is int pointer, can hold the address of an int. Spacing does not matter. I will tell you, I actually prefer this version, but you can do this version, and you can do this version as well. You may find that your organization prefers something. Usually, your tech lead has a preference and will want everyone to use that preference. But it doesn't really matter at the end of the day. So when we're assigning address to a pointer variable, we're going to define it. And again, we're saying, hey, this is not just an int. This is a pointer to an int. So this is actually going to hold nothing more than an address that points to an int. And when we then want to assign something to it, we're not going to assign the actual int, but rather we're going to assign we're going to put something in at the address of the int. So here's how that looks. So we're saying, hey, put the address of this variable, which is num, into this pointer called int pointer. As you can see from this illustration, num was already at the address of 4A00, and it already contained the data 25. We are now saying, please assign this address of 0x4A00 to the int pointer. So this int pointer variable now holds the address that is the location of this 25, or also known as num. Somewhere else in the program, we set up a variable num that also holds this data. But again, remember, this ampersand sign says don't give me the actual data of the variable, but give me the address of where this data is. So imagine somewhere, let's go ahead and kind of say, so up here we probably, in our code, we said int num equals 25. We did a literal, right? This num is got 25 in it. But because now down here we're using this symbol, we're saying don't give me what's actually in num, but give me the address of num. Hope that clears that up a little bit. Like I said, this can be one of the more challenging topics in C++. So take it easy. Make sure you go over this a couple times. Open up your online C++ compiler and play with some of this. Do some couts with ampersand signs and pointer signs and see what you get. So that way you kind of understand what's really going into these variables. Now, we can initialize pointer variables with the special value null pointer. So in C++ 11, we were introduced this new keyword called null pointer, and it represents the address of 0. So it literally is known as 0x00. But null pointer for us stands for that now at C++ and up, 11 and up, excuse me. So here's an example of how we would define that pointer variable and initialize it with the value null pointer. So we are saying, hey, again, we've got a variable called ptr that will hold an address that points to an int. And right now, we're just going to assign a null pointer to it, or basically the address of 0. So let's take a real quick look at a pointer variable, and this is going to be our int main. And this is kind of what we talked about already, where here I am assigning a variable int x with this literal of 25. And then we're also setting up a variable that will contain an address that points to an int. And because we want to be good developers, we always like to assign something as we're initializing. So in this case, because we don't know where it's going to be yet, we assign the null pointer. Now, here is the x variable that we talked about that holds 25, and we're asking x to give us the address of where it lives and assigning that to this pointer variable that we already have told the compiler, hey, this is not going to be an actual int, but rather a pointer to an int. And now we're outputting some of the information. So we're just going ahead and going to say the value of x is, and we're looking at x. But now we're saying the address of X is this. Well, okay. Well, that's great. And you can see the outputs here. But what can I do with that? Why do I care about the address? Why would I ever want to output the address? Well, you probably wouldn't. But we're about to talk about how to make use of that and how to make use of the pointer variable. And that's the indirection operator. So the indirection operator dereferences a pointer, and it allows you to access the item that the pointer points to. So up here, because we didn't have this indirection operator, we're going to actually see the address that's stored in that variable. But now, if we add this indirection operator, rather than seeing the address that pointer is holding, it's going to dereference the pointer and actually give us what it's pointing to. So kind of think of this as this star piece that we're looking at, the star operator, kind of does two functions, right? So it lets our compiler know that we're about to set up a variable that is a pointer to type of int. And we can also use it then with this type of variable, this pointer variable, to instead of, hey, I don't want to see the address of this of where this is pointing. Rather, I want to see what it's pointing to. So this is that second use. We can dereference the pointer to get the actual value. Now, at this point, you're probably going, okay, Professor Waits, all the addresses, all the pointers. I know. Again, take your time. You may want to watch this video more than once, or at least sections of it. And I can't stress enough, get into your quick and easy online compiler, write a couple of lines of code, play with this, and get much more familiar with what's going on with pointers and what's going on with the memory. So now we're going to add a little bit more to that program we've been talking about. Again, we've done everything up here just as normal. And here's the value in X printed twice. So the reason why is because we are actually outputting just X, which is stored in X. But we are also now outputting not the address of X, which is pointer is pointing to, but because we use this dereferencing star here, we're going to actually see the value that it's pointing to, which happens to also be X. And you can also assign data to where a pointer points to. So here we're saying, hey, we don't want to change, because you don't want to change the address that pointer is pointing to 100. That doesn't make sense. But you do want to change where pointer is pointing to 100. Again, this is the that program being continued, and it's now showing you that X has been changed to 100 because X is the data stored at that address. And because up here we changed what was at that address to 100, well, X is now changed as well. Okay, so let's take a break here, and that way you can go back and look at this video a little bit more and play with some things, get used to it a little bit. In the next video, we'll jump in and we'll talk about the relationship between arrays and pointers.